Hello viewers, welcome back to my channel. We are moving together from our first topic, that is the floating and sinking, and now we are moving on with our second topic, thin lenses. Okay, now in this topic we've been moving on. In the last lesson we looked at a magnifying glass. So a magnifying glass works on what principle? It works on the principle of the object being placed between the principal focus and the optical center, and the image forms on the same side of the object. It is magnified, it's bigger than the object, and that is the whole idea. We want the object to be magnified, and it has been magnified by simply putting it between the principal focus and the optical center. Now, in this lesson, we want to look at a simple microscope. How does a microscope work? Okay, we want to look at a simple microscope and see how a microscope works. So I'm going to delete this, we don't need it anymore. Remember, we are moving on with applications of converging lenses. We're looking at applications of converging lenses. Okay, so today we are looking at a simple microscope. Looking at a simple microscope. Okay, so let's get started. Now, to look at a microscope has two converging lenses. The first one, we call it the objective lens, and that is the lens that is closest to the object. Then there is the second lens, which we call the eyepiece. Now the eyepiece is where you place your eye. And as we're going to see in the lesson, the eyepiece is adjustable. So you can adjust it, and we are going to see why you will be adjusting the eyepiece. Okay, so let's say I have my first lens. So I have my first lens. Let me draw this. It's a long straight line like that. We draw it a bit up. Okay. So we know by now we have F, we have 2F. Then we have F, and we have 2F. Now we understand these terms. Now we are not new with them. So what would happen if I place my object between the center of curvature, 2F, and the principal focus, F? Okay, so if I place my object here, that is object O, and I've placed it between the principal focus and the center of curvature, 2F. Then, following the rules, we know the rules by now, a ray that comes to the lens parallel to the principal axis, that ray should be refracted through the principal focus. Like that. Okay? To the principal focus. The second ray is the ray that is coming from the object, passing through the principal focus. It's not very straight. Okay, so the second ray, we want a ray that is coming from the object to pass through the optical center, and by now we know that ray passes undeviated. Okay, so that ray is here. Of course, we expect something like that, where the two refracted rays meet. At this point here, we form our image. Okay, so I draw an arrowhead, and of course I draw a straight line to touch the principal axis. Now that is our first image. So we have used the first, this is the objective lens. That's the objective lens, O. And that lens, we have pressed it in such a way that the object lies between the principal focus and the center of curvature. And what do we see? We form an image which is behind C. By now we understand why it is forming behind C. And what are the characteristics of the image? Of course, the image is true. You can see these are true refracted rays. And it is inverted. But the most important thing, it is magnified, meaning it is bigger than the object. Let me call this image I prime. Let me call that image I prime. And to avoid confusion, I'm going to call this 2F naught, F naught, F naught, 2F naught. Why? Remember, we are using two converging lenses. So naught stands for objective lens, or principal center of curvature of the objective lens. Now, let me come now and put my second converging lens somewhere close to the image. Then I come with my second lens. Okay, and I call this the eyepiece. That's my eyepiece, okay? Eyepiece lens. Okay, now this eyepiece lens I'm going to put in such a way that this image is the object to the eyepiece. Pay attention. This image, the image of the objective lens, is the object of my eyepiece. Remember, this eyepiece cannot see the object. It cannot see the object. The object is on the other side of the objective lens. So it will see this image of the objective lens as its object. That's very important. Number two, I put this eyepiece in such a way that the object, which is the image to the first lens, the objective lens, falls between its principal focus and the optical center. This is the optical center of the eyepiece. And I want this object to fall. This is FE. So what does FE mean? The principal focus of the eyepiece. This is the optical center of the eyepiece, and this is the let me bring this eyepiece closer to the object. And remember, as we're doing this, the object lens is stronger than the eyepiece lens. The objective lens is more powerful than the eyepiece lens. And by that we mean it has a shorter focal length. So like that, something like that. So this is my center, that's my optical center. And the image of the objective lens, we have said, is the object of the eyepiece. Not only that, it is the object of the eyepiece, and that image, which is the object of the eyepiece, is you are putting the eyepiece in such a way that the object is falling between the principal focus of the eyepiece and its optical center O. Now by now I know you are getting where we are going with this. We want to form a second magnified image, but the image we want to form this time should be a virtue image. Remember, anytime the object is placed between the optical center and the principal focus, the image always forms on the same side as the object, and it is bigger than the object. It is magnified, only that it is virtue. Okay, so follow the rules. Oh, there is FE, and of course there is 2FE on that side. Okay, now follow the rules. The ray that is parallel and close to the principal axis, that ray should be reflected to pass through the principal focus. So that's our ray, the first ray. The second ray is the ray that is refracted through the optical center, and that should go undeviated. Okay, something like that. Now, the two lines are diverging. This principal focus is too close. It's not as the other one. Just to take it further away. So now we have something like that. That's much better. So we have two refracted rays that are diverging rays. Okay. Now from there we produce the refracted rays backwards. We produce the refracted rays backwards. Okay, that's much better. Okay, now let's look at the true rays. This is the first true ray coming from the object, and that is a true ray going away from the lens. The other ray, this is a true ray coming from the object, going away from the lens. Now anything I produce backwards is imaginary, it's virtue. So I'm going to produce this ray backwards. On a straight line, and I'm going to do the same to this. So they meet somewhere there. Okay, and that is where I form my image. Because that's a bit. So we point through the ray like that, and a straight line which is dotted, of course. Okay, that's our image. Now let's call our second image I prime prime. This image here is I prime prime. So I've formed two images. The first image is the image due to the objective lens, and the second image is the image of the first image, which is the object to the eyepiece, and the second image is virtue and magnified, bigger than the first image, which is the object to the eyepiece. Okay, now with that we have magnified the object twice. We have magnified the object using the eyepiece to form the first magnified image, which is true, and we have magnified it again by using the eyepiece, and we form a second image which is bigger than the first image, so but this time virtue. Now, we need to calculate something here. We need to ask ourselves, how many times have we magnified our image? Now, with this diagram, if I take this section here, instead of wasting it, let's calculate the magnification due to the first lens. Now, let's take the object distance, that is u naught. Let me call it naught. Naught simply means the object distance due to the objective lens. And then I take the distance from that point to where I have my first image, that distance, as v naught. Okay. Now I take the second object distance. Remember, the image is the object to the eyepiece, so I call it UE, where E is the object distance due to the eyepiece, and then I call this distance the image of the eyepiece. I call it VE. Please don't get confused here. There are two object distances and there are two image distances. So magnification due to the... Now, before I go to magnification, we need to go back to the lens formula. 1 over F equals to 1 over V plus 1 over U. Okay, but let's talk about F naught, U naught, and U naught. Why? Because we are dealing with objective lens. So focal length of the objective lens, image distance of the objective lens, and object distance of the objective lens. Now we want to get magnification from this equation. We have done it in another lesson previously. So multiply every side by V naught. So I get V naught over F naught equals to V naught over V naught plus V naught over U naught. Okay, which is equals to V naught over V naught is 1 plus V naught over U naught, V over V, object distance divided by image distance, divided by object distance is magnification. So let me simply call it M naught. Okay, so V naught over F naught equals to 1 plus M naught. Now, make M naught the subject. That's what we are interested in. So M naught equals to V naught over F naught minus 1. Let's take that as our first magnification. Now, what is magnification? M naught, magnification M naught is also given by height of object, not height of object, height of image over height of object. Magnification is either image distance divided by object distance, or image height divided by object height. So it can be presented as either image distance over object distance, or image height divided by object height. But our image, remember, image is I prime. So H I prime divided by H of object. This is our object. Okay. Now, so magnification is V naught F naught minus 1, or height of image over height of object, so is equals to V naught over F naught minus 1. I'm just substituting. Magnification is this, or it is height of image, height of I prime divided by height of object. So therefore, and so magnification M naught is the same as this. So this equals to that, equals to that. Okay. So we are saying height of our image I prime over H naught is V naught over F naught minus 1. So what am I interested in here? HI. So HI prime, height of this image, will be equal to h height of object into v naught over f naught minus 1. That's very important. I take that as my second equation. So let's continue. Okay. Let's say we want to calculate magnification due to the second lens, the eyepiece. Now, magnification due to eyepiece, we need to do the same thing we did here. 1 over f of eyepiece, that is focal length of the eyepiece, equals to 1 over UE plus 1 over VE, meaning object distance of the eyepiece and image distance of the eyepiece. Okay, multiply both sides by image distance VE. We know why, so that we get magnification from that lens formula. So this will be VE over FE equals to VE over UE plus VE over VE is 1. But we also know that VE over UE is magnification. So we call it ME plus 1. Okay? So you say VE over FE equals to ME plus 1. So make that magnification the subject. ME will be equal to VE over FE minus 1. That equation is very important. Let's call it equation number 3. But again, magnification is image distance divided by object distance, or image height divided by object height. So we can say that ME can also be given by height of image. But what image are we talking about this time? I prime prime. So height of I prime prime divided by height of object. But what is the object we are referring to? I prime. So divided by height of I prime. And that should be give us VE over FE minus 1. This is that, so this is also that. So VE over FE minus 1. So we are almost there. So what is I? Height of I prime prime? Height of I prime prime equals to HI into VE over FE minus 1. Okay? But what is HI prime? What is height of image I prime? It is H naught, V naught, F naught minus 1. So I can substitute, instead of height of I prime, I simply put that. So height of I prime prime is the same as H naught into V naught over F naught minus 1 into VE over FE minus 1. Okay. Okay. Now, up to that point, you see, I'm doing this because I don't want to delete anything. So what we have, we have 3 things. We have height of object H naught. We have height of the first image I prime, which is given by that. And we have height of the second image I prime prime, which is given by that. We're just putting things as they fall into place. Okay, now lastly, we are interested in total magnification. What is total magnification of our microscope? Now, to get M total, that will be what? The last image HI prime prime, divided by height of object. Remember, the object is the one we are magnifying. And to get the true magnification, it is the height of our last image, which we are going to observe. Remember the eye is here. So the eye is seeing this image. The eye is seeing the second image. So what is the total magnification according to your eye? It is the height of your last image, the second image, divided by the height of object. Magnification is height of image divided by height of object. Okay. Therefore, it will be hi prime prime divided by ho. So let's put it into place. What is hi prime prime? It is h naught into v naught over f naught minus 1 into ve over fe minus 1. Okay? Don't get lost. That is hi prime prime is that which I put here divided by h naught. Hi prime prime is that divided by h naught. So what do we get? Of course, h naught cancels with h naught, and we get magnification as v naught over f naught minus 1 into va over fe minus 1. Okay? Okay, so what is our total magnification? M total. So M total is equal to, let's go back, M naught is V naught F naught minus 1, which is M naught was magnification due to the objective lens. So it is M naught multiplied by VE over FE minus 1. Where did we have that? Equation number 3. Magnification due to eyepiece is VE FE minus 1. So multiplied by magnification due to eyepiece. What are we saying? That total magnification by a microscope is the product of magnification due to the objective lens and the magnification due to the eyepiece. The total magnification by a microscope is the product of magnification due to the eyepiece and the magnification due to the objective lens. Number 2, so what does that mean? If you choose an objective lens that has very large magnification, then you expect to get a very magnified image. So we go for microscopes are different. There are those that are the light microscope, the compound microscope, and the variation, the principle is the same. The variation is on the power of the lens. For a compound microscope or a strong microscope, this objective lens and the eyepiece, they have many lenses in them so that they have very strong refraction. And that is the magnification in a microscope, where there are two magnifying glasses. One we call the objective lens and the other one is the eyepiece. And the total magnification of the object is the product of magnification by the two, the magnification of the eyepiece multiplied by the magnification of the objective lens. Lastly, this eye where it is placed, we said we can be able to adjust the position of the eyepiece by moving the screws so that you bring the microscope up or down. And what for? So that the object, which is the image of the objective lens, falls between the principal focus and the optical center of the eyepiece. Okay, now that brings us to the end of our lesson. I hope you enjoyed the lesson. Don't forget to like and subscribe. Also share with other people. And I'm also hoping to see you in my next video. But now, until then, goodbye.